So on 6 and 8, we want to find the x-intercepts, which means we're going to have to factor the polynomial before we do anything. Always check for a GCF first, and then you're going to look at the number of terms you have and see if you're going to do maybe a sum or difference of cubes, or if you're going to do, that would be 2 terms. So if you have 2 terms, you'll try one of the cube patterns. If you have 3 terms, you're just going to do trial and error, which is the first way we factored, which is just the 2 sets of parentheses and pick your numbers. If you have 4 terms, you're going to have to do grouping. So right here we only see 2 terms, so we know that we're looking for probably a sum or difference of cubes, possibly a difference of squares, but we'll see what the numbers are once we pull out the GCF. We see that there's a GCF, there's at least an X GCF. So we want to at least pull out the x that we see. And then 27 and 8 don't have any common factors, so we can't pull out a number with my GCF. So I can pull out an x, and then I'm left with 27x cubed plus 8. Since I only have 2 terms in here that I'm trying to factor, I'm going to be looking for either perfect squares or perfect cubes. 8 and 27 are not perfect squares, but they are perfect cubes. 2 cubed is 8. You can check that. 2 times 2 times 2 gives you 8. And 3 cubed is 27. 3 times 3 is 9 times 3 is 27. So this is going to follow the cubic pattern with my a value being 3x. That's what's being cubed. That's what's being cubed to get 27x cubed. And with my b value being 2, that's the number that's being cubed to get 8. So if a is 3x and b is 2, then we're just going to follow my pattern. This is a sum of cubes, and so the pattern, I'll put the pattern up here. The pattern looks like this: a cubed plus b cubed. It's going to be a plus b, same sign as what we had over here. A squared minus opposite sign of what we had in my initial problem, AB, and then this last sign is always positive. So remember, SOAP. Same sign as what we have over here, opposite sign as what we have over here, and then this one's always positive. So this is the pattern that I'm going to follow, but I'm going to use my 3x instead of A, and I'm going to use 2 instead of B. So this is going to become x. So I'm going to have a plus b. So I'm going to have 3x plus 2. And then I'm going to have a squared. Well, 3x squared is 9x squared. 3x being squared is 9x squared. And then minus a times b is going to be 6x. And then b squared is going to be 2 squared is 4. So this is the factorization, and now I want to find my x-intercepts. So remember, we're going to set this whole thing equal to 0 to find x-intercepts. So I'm going to have 1 here and 1 here, and I'm going to have 2 solutions here. They may or may not be x-intercepts, but I know I'm going to have 2 because this is squared. So if I set x equal to 0, then one of my solutions is x equals 0. If I set 3x plus 2 equal to 0, then my other solution is going to be negative 2/3. Okay, and this is just a thing that you can memorize. If you try to solve this, this will never give you real x-intercepts or real solutions, which means that we do not have x-intercepts on the graph. So anytime you're doing this sum or difference of cubes, these are always going to be imaginary solutions. So notice that in the problem it asks us to find x-intercepts, which means that if they're imaginary, they're not there. So these will give me 2 conjugate pairs of, well, 1 conjugate pair, 2 imaginary solutions. So the only x-intercepts I have are going to be these 2 right here.